Folks, this video clip is helping you understand how you deal with complex fractions. Now, a complex fraction is nothing other than a fraction on top of a fraction. Okay? We need to simplify whatever this is and write it as maybe a over b or maybe an integer. We don't know what it's going to simplify to. Now, traditionally, you would deal with these two things separately. You would have your fraction line there, and then you would say, oh, the LCD of the top is a 6, and then I have 2 times 3 here, so I must multiply there with 3. Here times by 2, so I multiply the top with a 2. Then you would go to the denominator, and lo and behold, the same lowest common denominator of 6. Here I double up, so that doubles up to 8. Here I times by 3, so I must times the top with 3. Then you get to minus 1 over 6, minus 1 over 6. And at this point, if these two things weren't the same, you would multiply by the reciprocal of this. So you would traditionally do the tip and times. The result will be 1. Now, there's a more economic way to think about this. Okay, this is the traditional way. If I go and I look at my original fraction, I'm going to do my new introduction to you in red. The LCD of the top of that fraction is 6, and the LCD of the bottom of the fraction is also 6. So I'm finding each denominator, 2, 3, 3, and 2, and I find an LCD for every denominator in every fraction within the complex fraction. Then I'm going to say, let me multiply the top with a 6 and the bottom with a 6. Now remember, 6 multiplied by a half will bring me to 3. 6 multiplied by 2 is 12, divided by 3 is 4, and there's a negative in front. Divided by 6 times 4 is 24, divided by the 3 gives an 8. Minus 6 times 3 is 18, and 18 divided by 2 is 9. So it misses this step and it misses that one. It goes straight and it gets rid of your complex fraction. Your result is minus 1 over minus 1, which is 1. Okay, now it doesn't look much different in this example. Okay, but you'll see when we get to the algebraic fractions, it goes quicker. So if you didn't quite get that because it was a little bit too quick, just rewind and look at it again. Now let's apply that method to this problem. I've got 1 plus 1 over 1 plus this ugly fraction over here. The only denominator here is 6. Okay, so let me go to this component of my fraction, and I'm going to zoom in on that. The LCD is 6, so if I multiply the top part with 6 and the bottom part with 6, it takes care of this component for now. It doesn't dissolve the complex nature yet. Okay, so let's see what we get. We still have 1 plus 1 over 1 plus. Now 6 times 6 is 36. Careful now. 6 times 1 is 6, plus this, that cancels, so you have 6 plus 1, and this leaves us with 1 plus 1 over 1 plus 36 over 7. Now again, I still have a complex fraction. I need to get rid of this 7 denominator here. So if I multiply the top with a 7 and the denominator of the big fraction with a 7, it takes care of this 7. Now notice, by multiplying with 6 over 6 and 7 over 7, and the previous one I multiplied also with 6 over 6, I'm multiplying with 1. 7 over 7 is 1. So I'm not changing the value of any of these expressions in here. So 1 plus 7 times 1 is 7. 7 times 1 is 7 plus the 36. The 7 here cancels with that 7. So now it's quick. 7 over 43. So I get 43 plus 7, which is 50 over 43. This is 43 over 43 for 1, plus 7 over 43 gives 50 over 43. A nice way to get rid of this ugly fraction. Now let's see how this applies to algebra. For this complex fraction, I have two denominators. I've got x plus 1 and I have x minus 2 over there. So I know that my LCD for my fraction will be the product of the two. Okay, now let's see. If you did it the traditional way, the numerator, you will say, becomes, let me put the fraction line here, becomes x plus 1 in an LCD. So I have 3 times x plus 1 minus that x. I'm adding with an LCD of x plus 1. Here in the denominator, the LCD is x minus 2. So I end up with 2 times x minus 2 plus that 4. Now look at this. This becomes 3x plus 3 minus x at the top over x plus 1. All of that over 2x minus that 4 plus this 4 at the end over x minus 2. Now at the top I have 3x minus x is 2x plus 3, all of it over x plus 1 over 2x over x minus 2. And now only am I in a position to do what you guys call tip and times. I really don't like those words, but that's what we call it. Okay, so we get 2x plus 3 over the x plus 1. Now you'll see I'm putting things in brackets here. So I'm going to multiply, I'm going to tip this on its head. In other words, I'm reciprocating it, and I'm going to multiply by it. Okay, so my final result here is going to be the product of those two, but it's written in that form. Now let's see how my idea of a global LCD, folks, cuts quite a few steps. So I'm going to start the same sum here. 3 minus x over x plus 1 over 2 plus 4 over x minus 2. There we go. My global LCD is that multiplied by this. So what do? I take the top and I multiply it with x minus 2 times the x plus 1, and the bottom, in other words the denominator, must be multiplied by the same thing. So at the end of the day I'm multiplying with 1. So now remember, the 3 multiplies with that and this multiplies with both of those. So this leaves me with 3 times x minus 2x plus 1 minus x times, and the x plus 1 cancels. So I'm left with x minus 2 divided by 2 times that whole thing over there. So twice x minus 2 times x plus 1 plus 4 times the x minus 2 cancels the x minus 2, and I have an x plus 1. Now look at the poetry here, folks. I've got a common factor there. I have x minus 2 common. I got rid of my complex fraction where it took me 1, 2, 3 lines. All of this is no longer part of this sum, so you cannot stumble over ugly fractions. Okay? If I remove the x minus 2, I'm left with 3 times the x plus 1 minus that x, which I'll clean up now. And in the denominator, if I remove the bracket x plus 1 common, then I'm left with 2x minus 2 there, plus that 4. Okay, so x minus 2, and I get 3x minus x is 2x plus 3, all of that over x plus 1, and this bracket 2x minus 4 plus 4, and there I've simplified my ugly complex fraction, and I've left it in factorized form in any case. Okay, so folks, you can see you get rid of the ugliness of these problems quite quickly. if you deal with the idea of a global LCD to get rid of your complex fraction. A classic example of where this saves time comes from the grade 10 textbook for classroom mathematics. The old grade 10 textbook, there was an ugly problem that dealt with these type of fractions. Okay, so let's see. Our global LCD for this is a complex fraction, and that we're going to leave for later. The global LCD that we're going to work with is x plus 1 times x minus 1. So I take this fraction, I multiply the top with x plus 1 times x minus 1, and I multiply the denominator with exactly the same thing. Okay, and this is just going to tag along. So let's do that and let's see where it gets us. Here we can bracket these two terms together. We have x plus 1 all squared multiplied by x minus 1, and this was introduced to get rid of that. So that cancels that out, and I have minus x minus 1 left. Okay, in the denominator, so my complex fraction is gone. Okay, in the denominator I do the same. I multiply that with this bracket and I multiply the second term. If I multiply the first terms, I get x minus 1 all squared times x plus 1 minus the x minus 1 cancels that x minus 1. Remember, all of this is over 1. So those two cancel in the product, and in the bracket I'm left with x plus 1. This complex fraction is taken care of. Plus the x plus 2 tags along over x minus 2. Okay, now I can work a new denominator because I've got two fractions, LCD here, LCD there. So let's just see if I can't clean this up a bit. I get x minus 1 at the top. Comes out as a common bracket. Then I have x squared plus 2x plus 1, that thing squared, minus 1. Remember, if I remove that whole bracket, I leave a minus 1 in its place. Divided by x plus 1 can remove itself here as a common bracket, and I'm left with square that bracket, x squared minus 2x plus 1 minus the 1 that I leave in the place of this bracket, plus x plus 2 over x minus 2. Okay, let's see. I've got x minus 1. This cleans up quite nicely to an x squared plus 2x divided by x plus 1 multiplied by x squared minus 2x, and I still have to add the x plus 2 over the x minus 2. Okay, now you can see if I factorize this lot, that is x times x minus 1 times the x plus 2 over, this factorizes as x minus 2 times x plus 1 plus x plus 2 over x minus 2. Again, I'm telling you, this comes from the classroom maths book, the old edition, grade 10. Now you can see the LCD for these two fractions will be x minus 2 and x plus 1. Okay, so what do I have? I have x minus 1, x plus 2, and here I'm going to add everything over that LCD, x minus 2 times x plus 1. The only thing that this fraction does not have, it has everything in its denominator now, and yeah, the numerator stays what it is. This fraction needs to be changed, this denominator. I times with x times x plus 1. So I get plus the x plus 2 that was there, times with x, and then times with x plus 1. Okay, folks, and then I can remove common factors. The x is common, the x plus 2 is common, and what is left is this x minus 1, x and x plus 2 is common, plus the x plus 1 over there. All of that divided by x, x minus 2, x plus 1, and finally I get 2x times that x is 2x squared, x plus 2 over that LCD. Now this was one of the most difficult complex fraction problems I have seen in quite a long time. If you did it the traditional way, which is what the textbook did, let me just zoom out here, you can see the amount of fractions. These things are ugly. You keep your fraction, keep it there, and here you multiply by the reciprocal, by the denominator. In fact, there's a step missing between these two. So what we do is we say, no, we are going to try and get rid of the complex fraction from the word go. By looking at this part's LCD, it's gone, and now we deal with it as a normal fraction. So that was the old standard 8, the old grade 10 textbook for complex fractions. So remember, to deal with your complex fraction, you have the notion of a global LCD, multiply both numerator and denominator with that global LCD, and it takes care of the fraction. I hope that will help you.